Okay, so I'm nearly finished here. All I need to do is just type in theorem, and I think I'm good to go, man. You know what? I've been here for quite a bit of time doing this. I'm just going to take a break. I'm out of here.
Hey, I think he's gone.
What do you mean he's gone?
Yeah, he's gone. He's definitely gone. What is he doing here?
I think he's trying to teach him Pythagoras' theorem.
Pythagoras is what?
Pythagoras' theorem. Pythagoras' theorem. You know what? I could teach you Pythagoras' theorem.
Well, if you intend to, then I'm ready to listen.
Okay, I'll tell you what. Have a look at this then. So, Pythagoras' theorem. But before we start, I need to tell you something. I need to tell you something really important. You see this diagonal?
Yeah, I'm looking. What about it?
Well, in this diagonal, each corner of the rectangle is a right angle. We can construct a diagonal to form a right angle triangle. You see this one here?
Yeah, I'm looking.
Okay, what about this next one here? Look, in a square and a rhombus, the diagonals bisect each other at right angles.
Okay, I can see that it bisects. What about the last one?
Well, this last one here, in an isosceles triangle and an equilateral triangle, the altitude bisects the base at right angles. So, make sure you understand these three ideas. These three concepts are very, very important.
Okay, what next?
Well, I'll tell you what next. Whenever we're solving problems with Pythagoras' theorem, we need to make sure that these 6 steps are carried out.
What are these 6 steps?
Well, here they are, look. You can read them for yourself.
I prefer you read them.
Okay, so make sure you make a note of this.
Yeah, I'll make a note of it.
Okay, so let's solve the following problem. Consider the diagonal of a 5 centimeter by 8 centimeter rectangle. Find the diagonal's length in radical form and to the nearest millimeter. Right, so what we're going to do first is we're going to follow these 6 steps, okay? So in following those 6 steps, we're going to make sure that we draw the diagram first. So let's draw this down. Okay, we need the diagonal going across. And remember that we always have a right angle here. It's a rectangle, so we've got a right angle in the corner and we've got a right angle in this corner here. Okay, what are we going to do next? Well, according to this, we need to mark the known lengths. We know one side is 5. We know that this bottom length is going to be 8. What we don't know is this diagonal, which I'm going to call x. Now what? Well, this is what we'll do next. We'll write down Pythagoras' theorem, so a squared plus b squared is equal to c squared. We can replace our a with 5 squared, and our b with 8 squared, and our c with x squared. Now, what's 5 squared? We know 5 squared is 25. So let's just erase that and write 25. And we know 8 squared is 64. So let's move that away. And you know what? Let's get rid of that square. Here we go. And so 25 plus 64 will give us a value of 89. So we can have 89 is equal to x squared. And then finally, if we want to solve this, we're going to have to do the square root of 89. So the square root of 89 is equal to x. That's radical form. Or if we actually do the square root of 89, we'll get the value of 9.43398, which is basically 9.4 centimeters.
Great job. I really learned something from you today. Oh, I think he's coming back. Quickly, freeze.
Hey, what's going on here? Someone started my presentation. I better finish this off. Okay, let's carry on then. It says find the length of the diagonal of a square with side length 6.8 centimeters. Remember, this is a square, and it says give your answer in radical form and also as a decimal to the nearest millimeter. First thing first, we know it's a square, okay? So we're going to have to draw a square for this. So here we go, we're drawing a square. Now remember, in a square, we've got all right angles. So here's our diagonal of the square. Remember, it's right angles in each corner. And we know that the length of this square is 6.8 centimeters. So we can write here 6.8 centimeters. Now remember, all of the lengths are the same because it's a square. What are we going to do? So we've labeled our lengths. We need to label the unknown. In this case, I'm just going to call this x centimeters for the diagonal. And then I'm going to set up my Pythagoras, okay? So I can have here, in fact, let's just label this a, and we label this length b. So we can have a squared plus b squared is going to be equal to our x squared. Let's replace the values. So a is 6.8 and b is 6.8. We're going to square them. We're going to have x squared. Now 6.8 squared gives us a value of 46.24. And again, of course, we've got 46.24 again. And then that's going to equal to x squared. So let's add these values together. We end up getting 92.48. And if we square root it, we can get 92.48 is equal to x. Okay, we can leave it like that, or what we need to do is we need to find out to the nearest millimeter. So let's find the square root of 92.48. That gives us a value of 9.62 centimeters. Okay, so to the nearest millimeter then, that's going to be 9.6 centimeters. Okay, so to the nearest millimeter is 6 millimeters at the end there, or 96 millimeters. Okay, so let's look at another question. It says, what is the longest iron rod which can be placed flat across the diagonal of a 4 meter by 2.5 meter garden shed floor? So try this question for yourself and then I'll show you my working out. So remember, step one, let's draw our diagram and then we can label the lengths that we know. And then what I can do is I can label my lengths, okay? So I know that the top or the longest side of this rectangle is going to be 4 meters. And I know that the shorter side of this rectangle is going to be 2.5 meters, so 2.5 meters along the side. Okay, so we can label our unknown. I'm going to label it x. So let's set this up using Pythagoras. We've got 4 squared plus 2.5 squared, and that's equal to x squared. And if we simplify that, that's 16 plus 6.25, which equals to x squared. Now 16 plus 6.25 gives us 22.25. That's still equal to x squared. So the square root of 22.25 is equal to x. The square root of 22.25, if we plug that into the calculator, we'll get x is equal to 4.72 meters. Okay, have a look at the last question, and then when you're ready, I'll show you my working out. Okay, so we've got 3 roads, AB, BC, and CA from the right angle that form a right angle triangle. AC is 9 kilometers, BC is 5 kilometers. Liam rides his bicycle from A to B to C. Okay, what extra distance does he travel compared to if he were to go directly from A to C? So let's, in our diagram, let's label our points. We've got A, B, and C. AB is X kilometers. We don't know what it is. AC is 9, and then BC is 5 kilometers. So let's set this up using Pythagoras. We've got x squared plus 5 squared is equal to 9 squared. Now, because 9 is the hypotenuse, is the longest length, we're going to have to subtract 5 squared from 9 squared. So 9 squared minus 5 squared is going to give us x squared. 81 minus the 25 is going to give us the value of x squared. 81 minus 25 gives us a value of 56. So x squared is equal to 56. X is equal to the square root of 56. So if we do that on the calculator, x is equal to 7.48 kilometers. Now, that's not the end of the question, because it says, how much extra does Liam ride going from A to B to C if he were just to go from A to C? So the traveler, or in this case Liam, covers a total distance of the 7.48 plus the 5 kilometers, which is 12.48 kilometers. Now, what we need to do is we need to do 12.48 kilometers minus the 9 kilometers to find out how much extra Liam's riding. So that's an extra of 3.48 kilometers. So our final statement here is that Liam rides an extra 3.48 kilometers going from A to B to C rather than going just straight from A directly to C. Okay, as always, I hope you found that helpful, and remember, if you haven't already, subscribe, turn on notifications, and check out these videos from the playlist for Pythagoras. They'll be very helpful to amplify your skills, and as always, I'll see you in the next one.